Hi there, and welcome to a brand new series of Cisco Labs in GNS3 designed to help anyone studying for Cisco routing and switching exams such as CCNA or CCNP, or for anyone just interested in how to configure Cisco devices. My name's Robin Williams. I'll be taking you through the lab. So, without further ado, let's get into today's lab. Here, we've got a simple EIGRP topology. What we're going to do is we're first going to configure the network so that all of the interfaces are reachable by all devices in the topology. So we've got Astor, Regis, Taylor and Brown. So first thing we want to do is get onto the router. Okay, we're going to first off configure EIGRP. Enter into the router configuration mode. You can type in router EIGRP and give the routing process an AS number. Okay, one of the things to realize with EIGRP, which is different to OSPF, is that all the routers that you want to be part of the domain need to share the same AS value. In OSPF, the AS number is only locally significant. So once we've put the AS statement in, what we then do is we configure OSPF, put a network statement in for EIGRP for each of the interfaces that we want EIGRP to run on. So in this case, we go network. Okay, and it seems that my machine is there. We go. My machine just had a little hiccup there. Never mind. Okay. The other thing to remember, of course, is if you're using VLSM or non-standard subnets, is to create the no auto summary statement as well. It's probably sensible to do that as a first, so I'll do that first on the other devices while configuring EIGRP. So go into configuration mode, enter into router configuration mode as well. Bit of a typo there. And once again, by default, I've forgotten to add the network statement, the no auto summary statement in. I've just got excited and carried away. But there we go. So you just put the no auto summary in there, and let's go to Brown. On Regis, we will do the same. Now Regis has got this other loop back here, so we've got to include that in our statement as well. So we go. And you can see now that we're starting to get EIGRP neighborships formed. So on to the last one. Oh, did I forget? Yeah, I forgot to place in the network statement for the loop back on the Regis. So we'll just hop back over there. And that's done now. And there you can see another adjacency coming up. And you should hopefully see another one appear in just a second. There you go. You could see it on Regis beforehand. So now, if we look in the routing table, what we should see are all the routes for the network. So we see on Taylor here, we're seeing the route to Regis's loopback. We're seeing all the other physical interfaces available as well. And just to prove that, what I will do is you can first off check that you've got your relationships with show IP EIGRP neighbor, and you see the neighbor, you see your neighbors here. Okay, and then what we'll also do, just to check, we'll have a quick look at the routing table on here, make sure that all the routes are in the routing table. Okay, and then what we're going to do, we're going to ping across to the loop back on Regis. So this would really prove we've got connectivity through here, here, and here, or through here, 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 and there you go. So there we go. That's all done. So we now have a fully functioning EIGRP lab. So that's the first task completed. Now what we want to do is move on to adjusting how EIGRP works out its metric values. Now by default, EIGRP only uses 2K values, and if you look into the router itself, if you do a show IP protocols, which is a very helpful command, it shows you the routing protocols being used, and in our case it also shows you the K values being used. In our case it is K value 1 and 3, which I believe are bandwidth and delay. Now, one thing that you need to watch out for, actually, we'll skip that. We'll come back to that in a little minute. Okay. What we're going to do is we also want to include reliability, so that when EIGRP works out its metrics, it includes reliability in that equation. So the way you do that, go into the routing process again. In our case, it's EIGRP1. Now, if we type in metric weights, okay, this is where you configure the K values, but there's just something I need to show you before we do that. So we just hit a question mark. Now, it's asking you there for the type of service. This comes before all the other K values, and it's always a 0. So we're going to put a 0 in, 1 for bandwidth, 0 for load, 1 for delay. We then add in the reliability, and then K value 5, we're going to place that as a 0. Okay. What you should start to see happening on some of the devices now is the neighbor relationships will start to tear down as well, because one of the things that you need when you create EIGRP neighbor relationships is all the K values need to be the same. So if we was to have a quick look at there, you see we've no longer got any EIGRP neighbors. So what we now need to do is we need to hop onto the other routers, do exactly the same over there. Okay, and put the same AS values in. So it's a 0, 1, 0, 1, 1, 0. And you see there's a space in between. I forgot to put the metric weights command in, of course. And this is the command you want to see. So you can see here, neighbor relationship dropped. So let's get on to Taylor, fix him. I'm just going to copy it and paste it across. Okay, so Taylor, Brown and Astle have all had it. So we just need to go to Regis, and because we're already in metric router configuration mode on there, we can do there. Now what you'll see is that the adjacencies now come back up because the K values are back there as well. Okay, so let's just confirm that we've got all our neighborships back, or our adjacencies back. With a quick show IP EIGRP neighbors. There we go. So now we've got all our relationships back. So we're all good and ready to rock and roll again. So what we're going to do now, we're going to move on to some basic traffic engineering. Let me just tidy these up so you can see the topology again. Okay, what we're going to do is Regis here has a loopback address of 2.2.2.2. Now Brown at the moment, if you look in his routing table, he should have 2 routes to get to that address. Here we go. 2.2.0 can be found either through Astor or via Taylor. What we're going to do is we're going to force all the traffic through Taylor. You can also confirm this. If you do a trace, you can see here how it's load balancing between the two neighbouring routers. So what we do, just to change this, we go into the interface that is facing Astor, the path that we don't want, and we just basically just smash the bandwidth down so the metric becomes really unattractive. Okay, so if we now check the routing table, just give it a couple of seconds. There we go. It now only has one route. Okay, whereas previously it had the 2 routes, it's now being forced to go through the device Taylor. Okay, so we can also confirm that by doing another trace to that address, and you can see it's going through Taylor, hitting the Regis interface, and then back out onto the loopback address. So that's how to configure traffic. There are different ways to engineer traffic. That's a very basic, quick and dirty way, but this is a very basic lab. There are other things you can do in the future. So yeah, we can explore those at a later date. Now the last part we've come to is the trickiest part of the lab, which is to adjust the appropriate hold timers so that Astor will wait 30 seconds before declaring Regis and Brown to be down if it doesn't receive any hello packets. Now, by default, EIGRP sends a hello packet every 5 seconds, and a neighbour will declare a neighbour dead if it doesn't receive a hello in 3 times the hello interval. So the hold timer is 3 times the hello interval, or by default 15 seconds. Now, EIGRP's hold timer is a little different to how OSPF's hold timer works. In OSPF, the device itself declares how long it's prepared to wait for a hello. So in our case, it would be, if this was OSPF, Astor here would sit there and he'd say, right, I'm prepared to wait 15 seconds to receive hellos, and if I don't receive a hello within 15 seconds, I'm going to declare that you are dead to me, and I will tear down the neighbourship relation, the adjacency relationship. So, how does EIGRP work? It's completely counterintuitive. It's the opposite way round. What happens in EIGRP is the router, these routers, Regis and Brown, are going to tell their neighbour how long they should wait for them. So effectively what's happening is Regis is saying to Astor, hi, you should wait 15 seconds. If you don't hear off me within 15 seconds, declare us dead. And Brown is doing exactly the same. He's saying, Astor, if you don't hear off me in 15 seconds, then consider me as down. Okay, and then the adjacencies get torn down. Now, a way to check the hold time is if we go into Astor and we do show IP EIGRP, you know what's coming next, neighbours, you'll see the hold timer here. Okay, now because EIGRP sends a hold timer every 5 seconds, you wouldn't really expect it to see it drop beyond about sort of 10 seconds, I should imagine. There we go. There you go. So it got down to 10. It's now back up to 12. So there you go. Now what we're going to do, and the way that we change the hold timer, is we go to the interface on the device that is facing the router that we want to change the hold timer on. So in Regis's case, this is going to be interface fast Ethernet 0. And the command that we use for this, okay, is we use IP IP, hold time, EIGRP. We then place in the AS number and then the number of seconds that we're going to send the hold time for. Okay. So now Regis is telling Astor, your hold time for me is 30 seconds. So because we need to do this for both, Astor wants to wait for both Regis and Brown, we'll go to Brown and we'll perform exactly the same process. Go into the interface that is facing the neighbour that you want to influence. IP hold time, EIGRP, the AS number and the time that we want the hold time to go down to. So if we now go back to Astor, what we should see, we issue show IP EIGRP neighbours, what we'll see, you can see here, hold time's increased now to 30 seconds. So Astor is now prepared to wait 30 seconds for the hold timer, for a hello packet to come into it. That is basically the simple EIGRP lab that's done for you. I hope this has been useful to you. Good luck in your Cisco journey. Don't forget to hit the subscribe button to access more labs in the future, and I look forward to speaking to you soon. Bye bye.